Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about chemical bonding. In this video, we will learn about the electronegativity, ionic character of in covalent bond, non-polar covalent bond, polar covalent bond, and electrovalent bond. Now, electronegativity. Electronegativity is the property of an atom which increases with its tendency to attract the electrons of a bond. If two bonded atoms have the same electronegativity values as each other, they share electrons equally in a covalent bond. Usually, the electrons in a chemical bond are more attracted to one atom, the more electronegative one, than to the other. This results in a polar covalent bond. If the electronegativity values are very different, the electrons are not shared at all. One atom essentially takes the bond electrons from the other atom, forming an ionic bond. Now, the ionic character in covalent bond. If a covalent bond is formed between two like atoms, example in case of H2, the hydrogen atoms are identical, hence the shared pair of electrons is not distributed from the center. This molecule is called nonpolar because it is electrically neutral as well as symmetrical. While in HCl, covalent bonds are partially ionic if they exist between two dissimilar atoms and their ionic character depends upon the difference in electronegativities of bonded atom. The covalent bond between hydrogen and chlorine in HCl is partially ionic or polar covalent bond because of positive and negative charges on HCl. The value of electronegativity of hydrogen is smaller than the value of electronegativity of chlorine. So, chlorine carries slight negative charge and hydrogen carries slight positive charge in HCl. And as a result of it, polar covalent bond is formed. Now the polar covalent bond, this type of covalent bond exists where the unequal sharing of electrons occurs due to the difference in the electronegativity of combining atoms. More electronegative atom will have a stronger pull for electrons. Polarization of covalent bond. It is observed that in the sigma bond between two different atoms, the electron cloud is always closer to the more electronegative of the two atoms participating in the sigma bond. Due to this, there is a permanent dipole that arises in the bond and the covalent bond is said to be polarized. Polarity of covalent bond in water molecules. An illustration describing the polarity of the covalent bonds in a water molecule is provided above. The more electronegative atom is said to have a partial negative charge and the less negative atom has a partial positive charge in the polar covalent bond. The elements of different electronegativities always form polar covalent bond. For example, HCl, NH3, H2O, CH3Br. Now, electrovalent bond. Ionic bonds are also called electrovalent bonds. If the difference in the electronegativities of bonded atom is more than 1.7, then that bond is purely ionic or electrovalent. The bond between sodium and chlorine in the common salt, that is NaCl, is clearly ionic because the difference in the electronegativities is 2.1, that is more than 1.7. The bond formed between chlorine and chlorine in Cl2 is nonpolar covalent bond, while the bond formed between HCl is a polar covalent bond, and the bond formed between NaCl is ionic bond because the electronegativity of sodium is zero point 0.9 and the electronegativity of chlorine is 3.0. So the difference in electronegativities between chlorine and sodium is 2.1, which is more than 1.7. So chlorine gains the electron of sodium and sodium loses its electron and form ionic bond. Now, coordinate covalent bond. The coordinate covalent bond is also a special type of covalent bonding in which both electrons forming a bond are supplied by one atom only. The atom which supplies the pair of electrons for bond formation is known as donor, and the atom which accepts is known as acceptor. Arrow is commonly used to denote the bond, in which the head of an arrow pointing towards acceptor atom. The pair of electrons possessed by donor is called lone pair of electrons. This type of bond is also called dative covalent bond. It is the example of coordinate covalent bond. In ammonia, nitrogen forms 3 covalent bonds with 3 hydrogen atoms. It has a lone pair This lone pair form coordinate covalent bond with this hydrogen the hydrogen is acceptor and in ammonia the nitrogen is donor. It donates these two lone pair to this hydronium ion and form a coordinate covalent bond. The second, it is the example of ammonium ion, that is NH4 positive having 3 covalent bond with hydrogen atom and 1 coordinate covalent bond with this hydronium ion. Let's consider another example of the formation of hydronium ion. It is the formation of ammonium ion. that is NH4 positive. And the second example is the formation of hydronium ion. In water molecule, oxygen form two covalent bond with two hydrogen atom. One covalent bond and the second covalent bond. Oxygen has two lone pairs. This lone pair form the coordinate covalent bond with this hydronium ion. It is acceptor and water is donor. This lone pair attack on this hydronium ion and form coordinate covalent bond. Both the electrons are supplied by a single atom. Consider that in covalent bond, sharing of electron takes place. One electron is provided by hydrogen atom and the other electron is provided by oxygen atom. Similarly, it is also a covalent bond. One electron is provided by oxygen atom and the second electron is provided by hydrogen atom. Mutual sharing of electron. But in coordinate covalent bond, both the electrons are provided by this oxygen atom to this hydronium ion. It is denoted by an arrow. It is a coordinate covalent bond. That is the formation of H3O positive, that is hydroxonium ion. Now, metallic bonding. Sodium metal has one valence electron per atom. It crystallizes in a body centered cubic structure in which each sodium is surrounded by 8 nearest neighbors. These valence electrons are not confined to any particular atom. Instead, they are free to move throughout the crystal, so the resulting bond is relatively weak. That is why metals like sodium and potassium are soft and have relatively low melting point. Thank you very much. Allah Hafiz.